Here in example 7, we're going to continue using trig identities. We need to transform one side of the equation to look like the other. So on A, I'm going to try to get this left side and try to simplify it down to 1. So the first thing I notice is for cosine and secant is that I can trade out cosine and put in 1 over secant. So I'll change this to 1 over secant of theta times the secant of theta equals 1. Notice that secant of theta is on top and bottom, so they cancel each other out. I'm left with 1 equals 1. For B, I'm going to try to simplify this left side and make it equal to 1. The first thing I notice I should do is FOIL or distributive property. So secant squared theta minus secant theta tangent theta plus secant theta tangent theta minus tangent squared of theta. These cancel each other out, leaving me with secant squared of theta minus tangent squared of theta equal to 1. And then from there, I'm going to use this 1 plus tangent squared equals secant squared. So I'm going to replace secant squared with 1 plus tangent squared of theta minus tangent squared of theta equals 1. Tangent squared and negative tangent squared cancel each other out, leaving me with 1 equals 1. Okay, go ahead and try number 65, and I'll give you a hint. You should try to add those two fractions together first. Okay, if you got the answer, that's great, and get this side to look like secant or cosecant times secant. If you weren't able to get that, this is how I did it. First thing I noticed, to add these two fractions together, common denominator has to be cosine times sine. So I'll multiply this one times sine over sine, and that'll give me sine squared of theta over cosine theta sine theta. Then we'll multiply this one times sine over sine. Nope, that's incorrect. This one needs cosine, so multiply by cosine over cosine. And so that's going to be plus cosine squared of theta over cosine theta sine theta. Okay? When I add these two, now since I have a common denominator, I can add those two fractions together to give me sine squared theta plus cosine squared theta over cosine theta sine theta. I'm going to use my identity sheet here. Sine squared plus cosine squared equals 1. And so this becomes 1 over cosine theta sine theta. Well, this also can be written as, come down to here, 1 over the cosine times 1 over the sine. Put that all on the screen, there we go. And then I'm going to use my identities. 1 over cosine is equal to secant. So 1 over cosine is equal to the secant of theta. And 1 over sine. 1 over sine is equal to the cosecant of theta. And that's how I get the two sides to be exactly the same.